Hello everyone, welcome to Vision Tech Solutions channel. In this lab, I'm gonna talk about the HSRP protocol and I will show you how we can configure the HSRP in a network. First of all, I will give you an introduction about the HSRP protocol and why we use it in our network. If you look at this topology diagram, you can see that there are some clients connected to the layer 2 switch, and then for routing to the internet we have a router which functions as a default gateway with the IP address of 192.168.1.1. And right now we have only one router or one default gateway, and so that we don't have redundancy. So in case this router goes down, all these pieces will not be able to connect to the internet. So in order to address this issue, we need to have another router to have the redundancy in our network. So if you look at this diagram now, we have two routers, router 1, router 2. So now each PC, from each client or PC, we will have two paths to go to the internet. So one from router 1 and one from router 2, and we have two gateways. But here in this topology, again, there is the issue that which gateway we should use for these PCs, or if we just set the default gateway of these PCs to if put the default router 1 as a default gateway of these PCs, then if this one goes down, they don't know how to route the traffic to via router 2. So in this case, we have two routers, but we need a protocol that can do this job or provides the redundancy, and that is the function of hot standby routing protocol, or HSRP. So in HSRP, actually, we will create a virtual router which functions as a default gateway. And so a virtual IP address, we create a virtual IP address, and there is a standard actually virtual MAC address with 0000.0C07. This one is a standard for HSRP, and the rest depends on the MAC address of the router. So in this case, we actually create a virtual router and a virtual default gateway, which is 192.168.1.2. 54. So these clients actually will go to this default gateway, this virtual default gateway, but each routers has its own actually specific address, but the traffic will be forwarded to this virtual IP, and then depending on which one is the active router or which one is the standby, it will be forwarded to that router and it will go through the internet. So actually the control plane is synchronized, or there are hellos that are going back and forth between these two routers, which one of them functions as the active router. So traffic actually will be forwarded to this, but in fact the traffic will go to the default virtual IP address, but then from the physical router's perspective, it will go to router 1, which is for example, in this scenario, is the active router. And in case active router goes down, again, these PCs will ARP for the virtual IP address, but in that case, the traffic will be forwarded to router 2, which will take charge of the active router role. So if this link, for example, goes down, router 1 will become the passive or standby, and this one will become the active router. There are some states. There are 6 states: initial states, learn, listen, speak, standby, and active. When we activate the HSRP on the routers, actually it goes through these 6 phases or states. For example, the initial state indicates that HSRP is not running. It happens when the configuration changes or the interface is first turned on. The learn has not determined the virtual IP address, has not yet seen and authenticated hello messages from the active router. In the listen state, the router knows both IP and MAC address of the virtual router, but it is not active or standby router. Speak, it sends the periodic hellos. Standby, the router monitors hellos from the active router, and it will take the active state when the current active router fails, and active and standby. Actually, finally, the routers will go to these two states, active or standby. Okay, let's jump to the our scenario. Here we have two PC0, PC1. We have one layer 2 switch. These two PCs are connected to this switch, and we have one ISP, and the loopback address of this router actually represents our internet access. So these PCs should be able to ping the loopback IP address of this router, which here in this topology it represents our internet access. And we have two routers actually in the core. Let's say this is the core of the network, so these PCs need to connect to these two routers or the default gateways in order to get access to the internet. We have the HSRP with this virtual IP address 192.168.1.254. We need to configure, and these two routers, router 1, router 2, each one has gigabit 00 facing south toward the endpoints. One with the IP address 192.168.1.252, the other one 1.253, and we have these two networks. As you can see, there's a different network connecting these two to the ISP. One is 172.16.1/24 and 172.16.2.0/24. Because we don't have dynamic routing configured in this network, we have a static routes. So from router 1, in order to reach the ISP, we send the traffic to this interface, which is 172.16.1.1.1, as you can see. On router 2, there is also one static route, 172.16.2.1. Like to reach to the loopback address, we send the traffic to this interface. Now for the ISP, as you can see, we have floating static routes. I have another video about floating static routes in the CCIE section that you can go and watch. We have two routes with two different administrative distances. So one with the administrative distance is 10 and the other one is 20. 10 is preferred, and the reason why we put 10, because we want the ISP to send the traffic to the active router. So the router which functions as the active router actually forwards the traffic. So because in this scenario, we want to manually configure our 2-bit to be the active router with the IP address of 172.16.2.2. So I want the ISP in the return traffic, when these PCs send the traffic to the ISP, the traffic in the return traffic should go to router 2. That's why the administrative distance of 10 is set here to 2, and in case this route is not available, send the traffic to the alternate route, which is router 1, because if this one is not available, it will be active. Router 1 will be active, and then traffic will be sent. Okay, now let's go and do the configuration of the HSRP. I connect to router 1. So first I want to show you the static route which has been configured. So this is the static route from R1 going to the if we want to reach the loopback IP of this ISP router, we send the traffic to this interface. Show IP interface brief. So you can see gig 00 is 192.168.1.252, and this interface towards the ISP is 172.16.1.2. So in order to configure the HSRP, I go to gig 00. The command is a standby 1 IP. I put the virtual IP 192.168. The virtual IP is 1.254. Not 1.254. I use the standby version 2. And I want to enable the preemption. So it means if it goes to the standby and then for example, the router reboots, then it can resume its active role. So standby 1 preempt. So if I don't change the priority will be 100. Okay, the default is 100 and the higher priority is more preferred. So if I want the router to be the active router, I have to change its priority. So at the moment, show standby, and it went to the active role because I haven't configured it on the other one, and the priority is 100, and this is the virtual IP and this is the virtual MAC. Now let's go to router 2. I will do the same. Standby 1, I put a group number. This is the group number. I put the IP 192.168.1.254. Standby version 2, standby 1 preemption enable. And because I want this router to be the active router, I change the priority. Standby 1 priority, I put 105, and the reason why I put 105 is higher than 100. And I also want to track these two interfaces. If one of these interfaces goes down, it will decrement the priority to lower than the priority of R1, and it will decrement 10. So if we decrement the priority from 105 deducted by 10, it will be 95, which will be lower than R1. So it will be a standby router. So standby 1 track gig 00 and track 01. Show standby. So this one now is active because I put the higher priority. If I go to router 1, and you can see that it became the standby router. Why? Because it has a lower priority. Okay, because we have the routing also set, we should be able to ping from the PCs to so I'll just show you again the configuration. R1, so standby version 2, standby 1 the virtual MAC address and preemption, and R2 the same thing. If I go here, standby 1 the virtual IP address, version, preemption, priority, and I'm tracking these two interfaces. Now on the PCs, I have configured the default gateway to be the HSRP virtual MAC address, and each one is 192.168.1.1, and PC1 the same thing. So the default gateway is set to the virtual IP address of HSRP, and the MAC address, the IP address 192.168.1.2. Now let's check if we can ping the ISP. Okay, and you can see that I can ping. Now let's do this trace. I want to see where the traffic is going. It should go from R2, which is 1.253. And you can see that I'm going from the active router going to the ISP. Now I put the continuous ping, and let's see. Now what I want to do, I want to shut down one of the routers and see if my HSRP actually works. So as you can see from PC1, I can ping the ISP, and this is the active router. The traffic is going. Now I go to router 2, and I let's first also write the configuration so I will not lose my startup config. Okay. Now in R2, I'll go and now just check the traffic. I shut down. I turned off this router R2, and let's see, we are losing the ping, and soon we should resume the traffic because this one should become active. If I go to R2 now, and you can see a state changed from standby to active, and see now R2 is down and the traffic is going through. If I go to R1 now and show standby, and you can see it is active, and just we lost 3 pings. And if I now trace, and there you go, I'm going through R1. Now I turn this on, and I keep the ping going so I can ping. Of course, the traffic now is going through R1, and let's see when the R2 comes back on, what happens. It should go to the active state again. So it is in this peak and active because I use the preemption and the priority is higher. And soon again, as you know, we can see that the traffic is going. If I trace now, and you can see that again traffic is going through R2. So this shows that our HSRP actually is working. So we configured HSRP on these 2 routers, and we have redundancy. In case one of these routers, like the active router, goes down, the other router will become active and it will forward the traffic. I hope this lab has been useful. If you found this lab useful, please don't forget to like, subscribe, and share it with your friends. Thank you. See you in the next lab.